Welcome, explorers and the future visionaries, to this green key to space. Today, we are embarking on a journey not just to stars, but into the very fabric of how we might sustainably live among them. For decades, the dream of living off world, on the moon, on Mars, or beyond, has captivated humanity. But practicalities, sheer logistics of building and sustaining life in the cosmos have been a colossal hurdle. Think about it. Every single nut and bolt and pieces of equipment we send into space cost an astronomical amount, not just in money but in energy and resources. And once it is up there, what happens to the waste? How do we build self-sustaining environment when every resource is precious and finite? The traditional method of space constructions are heavy, inflexible, and create immense waste. We need a new approach, a greener approach. And that, my friend, brings us to the unsung hero of our off-world future, which is the bioplastics. Now, when we hear about plastics, you might immediately think of pollution, landfills, microplastics in our ocean, and you will be right in this context in a conventional plastic way. But bioplastics are different breed altogether. They are materials derived from renewable biomass sources, things like cornstarch, sugarcane, algae, even food waste. Unlike their petroleum-based cousins, many bioplastics are biodegradable, and it is can be easily become a compost, or can be recycled in entirely new ways. They represent a fundamental shift from linear take, make, dispose model to more circular, sustainable ones. So why are these humble, earth-friendly materials suddenly getting so much attention from the space community? The answer lies in their unique properties that align perfectly with challenges of off-world living. Firstly, sustainability at its core, that is very important. We cannot just keep launching everything we need from Earth. Future space colonies will need to be largely self-sufficient. Bioplastic derived from renewable sources offer a pathway to truly sustainable resource utilization in space. Imagine growing the raw material for your habitat panels in a Martian greenhouse rather than mining heavy material or metals from the earth. Secondly, it is lightweight. Every kilogram counts in space. Traditional construction material are incredibly heavy. Bioplastics, often lighter than traditional plastics and metals, offer a significant advantage, reducing launch cost and increasing payload capacity for more essential items. Thirdly, and perhaps most exciting, is their versatility and adaptability, especially for 3D printing. This is where the magic truly happens. Imagine a habitat on Mars, not built piece by piece from Earth-shipped component, but printed on demand using local source material mixed with bioplastic polymers. We are talking about printing structural elements for the habitat, tools for repair, spare parts for machinery, even customized medical devices or food packaging. This on-demand manufacturing capability is the game changer. It means less reliance on Earth's supply chain, greater resilience for off-world missions, and the ability to adapt to unforeseen circumstances with unprecedented speed. But the potential goes even deeper. Think about the integrated life support systems. Bioplastic can be engineered to be biocompatible, meaning they can safely interact with living organisms. This opens up possibilities for creating closed loop bioregenerative life support systems. Picture bioreactors made of bioplastics growing algae for oxygen and food, or hydroponic systems cultivating crop in transparent bioplastic tubes. We could literally be growing our homes and our food all powered by sustainable materials. And let's not forget waste management. In space, waste isn't just an inconvenience, it is critical threat to mission safety and long-term sustainability. Traditional plastic breaks down into microplastic that can contaminate environment and equipment. Bioplastic, however, offers a pathway to managing waste efficiently, potentially even composting it back into nutrient for further bioplastic production. A true circular economy in space. Now, you might be thinking, this sounds great, but is it just a pipe dream? Not at all. The science and engineering are rapidly advancing. On Earth, bioplastics are already used in a wide range of applications from medical implants to sustainable packaging, automotive parts to consumer electronics. The materials are proven. The challenge now is to adapt them for unique rigors of space. So, what are the specific applications we are talking about, especially when we are thinking of space exploration? First is the habitat construction. Imagine an inflatable bioplastic dome that hardens when exposed to UV light, or modular structure 3D printed from a composite Martian regolith, the Martian soil, and the biopolymers. These structures could be lighter, easier to deploy, and more adaptable than anything we have conceived before so far. Second is the tools and equipment. Wrenches, spare parts, scientific instruments, all could be printed on demand. This would dramatically reduce the need to ship these items from Earth, freeing up valuable cargo space during launch. Third, food production systems. So, hydroponic trays, aeroponic systems, even components for insect farms or algae bioreactors could be made from safe, durable bioplastics. Number 4, waste recycling and resource recovery. Bioplastic can be designed to break down or be reprocessed, feeding back into the system, creating a truly circular economy for materials in space. It is not just about building big things, it's about the small everyday necessities. Think about custom fit equipment, ergonomic tools, even personal items made from bioplastics that can be printed or molded on site. This level of customization and on demand production vastly improves the quality of life for astronauts on long duration missions. Imagine being able to print a comfortable chair or a personalized utensil, which is small. These are all small comfort that can make a huge difference in the isolation of space. But when these items are no longer needed, they can be broken down and reused, minimizing the waste and maximizing resource efficiency. And of course, it is not without its challenges. The space environment is incredibly harsh. We are talking about extreme temperature fluctuations, radiation, and the vacuum conditions. Bioplastic need to be engineered to withstand these stresses. Research is ongoing to develop materials that are robust, radiation resistant, and maintain their structural integrity under extraterrestrial conditions. Another challenge is the development of in situ resource utilization, or ISRU, to create a bioplastic feedback stock. While we can bring some raw material from Earth, the ultimate goal is to grow or synthesize them directly on Moon or Mars. This means developing advanced biotechnologies and biomanufacturing processes suitable for off-world environment. Now, this is where the brilliant minds of material scientists, astrobiologists, and engineers converge. They are exploring everything from using algae grown in Martian regolith as a feedstock to developing advanced enzymatic processes that can break down waste into building blocks for new bioplastics. The innovation happening in this field is truly breathtaking. The implications of mastering bioplastics for space are profound. It is not just about building a few structures, it's about enabling entirely new paradigms for space exploration and settlement. It will bring a lot of advantages. Number one is reduced dependency on Earth, and this is very critical for truly independent and long-term missions. Second is the increased mission flexibility, and bioplastics will help us adapt and innovate on the fly, responding to challenges without waiting for resupply missions from Earth. Third is the economic viability. Perhaps this is the most important one in today's context. Bioplastics will, lower the launch cost, and more efficiently resources are, being used or blast off for ventures which are off-world in a more economical and feasible way. Next is environment responsibility. So, extending our commitment to sustainability beyond our home planet. And in space, if there are waste, then it can multiply and beyond repair. So this is also very, very important. Imagine a future where Martian settlers are not just surviving but thriving, thanks to the closed loop system enabled by bioplastics, where their homes are literally growing around them, providing food, oxygen, and shelter, where every piece of waste becomes a resource, feeding back into the cycle of life and construction. So this is just about building structures. It's about cultivating life in the harshest of the environment. It's about creating an off-world ecosystem and not just a base. The green key to space isn't a single solution but the powerful enabler. It's about combining cutting-edge material science with biological processes to create truly regenerative systems for humanity's expansion into the cosmos. It's about taking the lessons learned from our own planet about sustainable living and applying them to the greatest challenge humanity has ever faced, and becoming a multi-planetary species. The journey to off-world living is a long and complex, but with every breakthrough in bioplastics, we are getting closer. We are moving into the into the vision of industrial metal and steel space colonies, to one that is more organic, more sustainable, and ultimately more harmonious with the universe around us. And this isn't just about technology, it's about philosophy. It's about bringing our responsibility to the environment with us as we venture into the final frontier. It's about demonstrating that humanity can expand its reach without expanding its footprint. So the next time you hear about bioplastics, don't just think about eco-friendly packaging. Think about the possibility of growing our homes on Mars. Think about self-sustaining communities beneath alien skies. Think about the green key that could unlock humanity's true potential among the stars. The future of space is not just about rockets and robots. It's about responsible innovation, sustainable materials, and the ingenuity to build a lasting legacy beyond Earth. Friends, thank you for joining me on this green key to space. Keep looking up, keep thinking green, and just in case if you have any comment, leave them in the comment section below. And I will see you again in the next one very soon. Bye for now.